Okay. So here what happens is you get x square here and 10 to the power of 4. Coefficient is 1 and here it is 4. Therefore answer is 1 by 4. We'll move on to the next problem. Limit if f of x is equal to x to the power of 100 by 100 plus x to the power of 99 by 99 plus etc. x square by 2 plus x plus 1. Find f dash of 0. This is a problem on derivative. So what is the method for this? So first differentiate this. F dash of x is equal to x to the power of 99. Because you know x to the power of 100 differentiation is 1 by 100 is a constant. It's 100 x to the power of 99. X to the power of n is n x to the power of n minus 1. This will cancel. Similarly, this is x to the power of 98 plus etc. This is x plus 1 plus 0. So this is f dash of x. They have asked you to find f dash of 0. So everything is 0 answer is 1. I think again another year they have repeated a similar problem. We'll work that also. Instead of 100, they made this 200, 200, 119, 199, etc. etc. They instead of f of x, they called this as g of x. That's all they can do. They can't do anything more than that. The question is same. Without working, you can take the answer as 1. But same work. If at all, if you want without working, just write 1 or 2 steps. This is g of x. G dash of x is equal to x to the power of 199, etc. etc. 1 plus 0. Then you go for g dash of 0. So this 1 will remain. So sometimes they repeat the same problem there. Simple changes. This one such problem. Next problem. If y is equal to f of x square plus 2 and f dash of 3 is 5. Just concept oriented problem. If you are strong in concept, you can work this problem easily. Then dy by dx at x is equal to 1. You must realize you are going to use chain rule for the differentiation of this. What is dy by dx? First, let us differentiate f of anything is f dash of x square plus 2. So we enter inside x square, we are going to differentiate. We get 2x, 2 is 0. Now at x is equal to 1, this is going to be f dash of 3 because x is equal to 1 into 2. But f dash of 3 is going to be 5 into 2 answer is 1. Very simple problem, provided you understand this. So with this, we shall move on to the next problems of next type of problems connected to differentiation only. If all problems selected from the examination paper, if y is equal to tan inverse of x whole square, then x square plus 1 whole square into y2 plus 2x into x square plus 1 into y1 is equal to, what's the question? This is a standard problem. If you can remember, the answer is 2. Supposing you don't remember, you can work fast. No need of writing all the steps. You can write dy by dx is equal to 2 tan inverse x or 1 plus x square. I will call this as y. 1 plus x square into y1 is equal to 2 tan inverse x. So when you differentiate this, 1 plus x square into y2 plus 2x y1, 2 or 1 plus x square, immediately you can take the answer as 2 because there is cross multiplication solution. We have worked number of problems at the moment. If you can remember, write the answer as 2. If not, no need of completing. The moment you get 2 over this, when you cross multiply, you are going to get that. Next problem. If y is equal to log of 1 minus x square over 1 plus x square, then what is dy by dx? They would have given 4 answers. I'm not writing all of them. We'll complete the problem. Normally, many of the students, what they will do is they will first differentiate log 1 over, then they use quotient rule. But remember, whenever log is there, use the formula of logarithm. Log mn is equal to log m plus log n. Log m by n is equal to log m minus log n. Log m power n is equal to n log m. These 3 formulas you need to remember. Here you are going to use second formula. So y is equal to log of 1 minus x square over minus log of 1 plus x square. You differentiate this, you get minus 2x over 1 minus x square minus 2x over 1 plus x square. Simplify this, take minus 2x common. Take LCM also 1 plus x square plus 1 minus x square or 1 minus x to the power of 4. This will cancel. The answer is minus 4x 1 minus x to the power. I worked it out fast. Just to give an idea that you can work fast. So let me explain. Log of a by b is log a minus log b. This is log a and this is log b. Difference of log is 1 over 1 minus x square. 1 is 0 minus x square is minus 2x. Similarly, you get plus 2x. I take minus 2x common. When I take minus 2x common, what do I get? 1 over 1 minus x square plus 1 over 1 plus x square. Then we have to take LCM, but practice this. Taking common and taking LCM, we are done in one step. There is no need of cancelling. The moment you look at this, you know this will cancel, you get minus 4x. And then they would have given 4 answers. You have got to take the right answer. If x is equal to a cos cube theta, y is equal to a sin cube theta, then 1 plus dy by dx whole square is equal to. So let us find dy by dx. This is 3a sin square theta cos theta. This is minus 3a cos square theta sin theta. So sin will cancel, 3a will cancel. You get minus tan theta. So 1 plus, so what is 1 plus? This is equal to 1 plus tan square theta. That is equal to 6. Write as minimum as possible. There is no need of writing. Don't start writing dy by dx and then dy by dt and then dx by dt, then dividing it. All that you can avoid. Even this also there is no need of writing. You scribble it. You'll get tan theta 1 plus tan square the secant square theta. The next problem. Normally they give standard problems only. You should have worked them, and I would rather advise you. You can remember the answers for these problems because there are only few standard problems like that. One such problem is if x to the power of y is equal to e to the power of x minus y, find dy by dx. I would remember the answer as log x over 1 plus log x whole square because it's a standard problem. So what you can do is some of the standard problems, you list them separately, just memorize the answer so that we can tick that. But let me work the problem. How do you work this problem? You take log on both sides. Y log x is equal to x minus y because log e to base c is 1. This is a peculiar problem. That's why I told you to remember the answer. If you start differentiating directly, you will not get the answer. Because in the textbook or the examination, they will give the problem, prove that this answer is given. So what we do is, we write this as y into 1 plus log x is equal to x. So y is equal to x over 1 plus log x. The moment you get this, you can satisfy the answer because when you use quotient rule, denominator should be 1 plus log x whole square. If there is only one answer, you tick that. If not, you have got to work it out. You can work fast. Dy by dx will 1 plus log x into 1 minus x into 1 by x over 1 plus log x whole square. So you get this answer because this is 1 and 1 will cancel. So these are all standard problems where you can remember the answers. There's another one such problem they have given, and they keep repeating this. So there is no need of working them. I would rather advise you to remember the answers for these problems. If x to the power of m into y to the power of n is equal to x plus y to the power of m plus n, then dy by dx. This is another standard problem. The answer is y by x. You can remember. Anyway, let me work also. This is m log x plus n log x. The second reason to remember the answer is you don't have place to work. Addition sheet is not given to you. And if you can remember the answers for these problems, you are saving a lot of time and you are sure of marks. So these are all, I can say, first set problems where they depend on the memory. So this is m plus n into log of x plus y. Differentiate this. I won't advise you differentiate it. I would rather say different and I remember the answer. They may change this m and n to p and q also, chances are there. Whatever is given, the answer is y by x. Y is equal to, so the answer for this problem y by x. If y is equal to tan inverse of sin x over 1 plus cos x, then dy by dx they ask. Remember, answer is 1 by 2. If they give a cos x over 1 plus sin x, it is minus half. So these are all standard problems. Anyway, let me work it out for you. Tan inverse of sin x is 2 sin x by 2, cos x by 2, 2 cos square x by 2. You get y is equal to x by 2 because tan inverse of tan x by 2, therefore dy by dx is half. No need of working, these are all standard problems, you can remember the answers. The next problem, y is equal to log of x plus root of 1 plus x square, then dy by dx is equal to, no need of working, the answer is 1 over 1 plus x square. How to remember this? Because you know the integration of this. root of 1 plus x square is log of x plus root of 1 plus x. So this is. Otherwise, if you start writing log is 1 over x and all that, there is no paper also, time also is not there. These are all standard problems. And these are the problems where you can be very sure of getting the marks. It requires only to identify those problems. That is why you have to work the previous year's papers. So this is a problem of integration. The answer is this. Therefore, you differentiate that, you get that. And in fact, while working problem integration, some cases can differentiate the 4 answers and get the solution, pick the right answer. That is also possible. In some of the, not always. The next problem they have given is y is equal to log of a minus x over a plus x. You can't remember, but you can work fast. This is log of a minus x minus log of a plus x dy by dx minus 1 over a minus x minus 1 over a plus x. Take minus 1 common and take LCM a plus x plus a minus x over a square minus x square. X and x cancels, minus 2a over a square. Similar to the problem that we worked earlier. The next problem is if y is equal to log of x to the power of x. X to the power of x. So you need to remember the formula. Log m power n is n log m. So you can write the problem as y is equal to x log x. dy by dx is equal to log x plus 1. Y plus 1. To differentiate, keep log x difference 1. When you keep x and differentiate log x, you are going to get 1 by x, that will cancel. So when you search for the answer, this answer was not given. They are given the answer log x to base c. The second one was log ex, something like this. So what the examiner has done is he has written this as log x to base e plus log a to base c. That is log ex to base c. These are the another type of tricks played by the examiners. So you have to, the answer may not be given in the format that you have got. You must be able to convert it to that form. So 1 plus log x is the answer, or log x plus 1 is the answer. What is the book answer is, or the correct answer in the paper is this. So you can write 1 as log a to base c. Then you are using the formula log m plus log n. Log n. So when you solve the previous papers, you get these ideas. The answer is not given in a format that we get. They would have twisted the answer, you must be able to identify it. What are the answers given for this problem? Before answer, I will tell you what are the answers given. The previous log x to log x. The second answer log x by e. Third answer is log ex. The fourth answer is log e by x. All possible mistakes that you can do, you should realize this answer. How do you know that you have to simplify? Because the answers given are not matching with the answers you have got. Therefore, the answer should be in the, you have to express in one of the form. So one can be written log a e to base c, then you can use the formula. So these things are very, very important when you are solving the examination paper. Concentrate more on this, so that when such problems are given, you can directly work it out. The next problem they have given is if y is equal to secant inverse of x plus 1 over x minus 1 plus sine inverse of x minus 1 over x plus 1, then dy by dx. The moment you see this problem, you should understand nobody can work this in CET. Because you have got to use second inverse chain rule and then you have to use quotient rule. So immediately you get an idea. This is a problem with some important results is connected. So what you can do is you can convert secant inverse as cos inverse of x minus 1 over x plus 1. So y is equal to 5 by 2. What's the formula? Sin inverse x plus cos inverse x is equal to 5 by 2. X can be anything. What is the meaning of x? Both terms should be same. So when you convert this x minus over x plus 1, so if you realize that what is the differentiation, it is 0. So this is the point where you get an idea. This problem is twisted. This is the problem where we cannot get the solution on differentiation. We are going to use the rule. Immediately you should recollect. So trigonometry formula is very helpful here. If y is equal to 2 over 1 plus cos x. So this is not just 2 over log of, because if it's 2 over 1 plus cos x, directly you can differentiate. Log of 2 over 1 plus cos x. So y is equal to log 2 minus log of 1 plus cos x. Don't write the formula. If you write the formula, it's going to complicate it. To differentiate this, dy by dx, log 2 is a constant. 1 plus cos x is sin x over 1 plus cos x. But they have not given this answer. What is that they have given? They have simplified this. This is 2 sin x by 2 cos x by 2. This is 2 cos square x by 2. 2 and 2 cancel, 1 cos cancel, tan x. So this is one problem where you need to use this trigonometric formula because you get this answer. Log 2 is a constant. How did I got a minus plus sign? Because cos x minus sin x is minus. So we can't leave the answer like this. You have to use the formula and get it. That's the answer given. Tan x by 2 is the correct answer. If y is equal to 2x to the power of n plus 1 plus 3 over x to the power of n. See, the moment you see this, you should realize we have got a problem in the regular class. Ax to the power of m plus n plus b by x to the power of m. The answer is m square y. I'm sorry, m into m plus 1 into y. So you can remember, you can take the answer as n into n plus 1 into y, or else we'll work it out. What is the differentiation of dy by dx? They have asked what is d square, then d square y by dx. D square y by dx. So this is 2 into n plus 1 into x to the power of n minus 3 into n into x to the power of minus n minus 1. To differentiate for the second time, d square y by dx y is equal to 2 into n plus 1 x to the power of the what they have asked in this problem is this n minus 1. This becomes plus 3 into n plus 1 to the power of n minus 2. So what is x square d square by what is asked? That's the question asked. So multiply by x square. X square d square by dx square is equal to. So remember for this problem, x square dy d square by dx square is equal to n into m plus 1 or n into n plus 1. So here it is n into n plus 1 can be taken as a constant. We get 2x to the power of n because 2 plus n minus 1 is n plus 1 and plus 3 by x to the power of n. This is nothing but y. Therefore, n into n plus 1 into y. So here also I would suggest you, these are all standard problems. The moment you see this, immediately pick the answer n into n plus 1 into y. The second point is, when you look at the answer, at least you can remember, oh, I worked a problem n into n plus 1 into y. There also you get a hint. And this is a problem where you can save time. Otherwise, differentiating this has two problems. One is paper, second is time. If y is equal to sin square x and x is equal to cos square x, what is d by x? The answer is 1, minus 1. You need not work. You can remember, I told you in the last class also, if y is equal to sin square x, dy by dx is sin 2x. Y is equal to x square. Sin square theta x equal to cos square. So dy by dx sin 2x. If y is equal to cos square x, dy by dx is minus cos 2x. When you divide one by the other, you get minus 1. A problem on parametric function, which you can write the answer without working. If you remember, sin square x on differentiation gives sin 2x, cos square x on differentiation gives minus sin 2x. I think we'll close the class today, or we'll work one or two problems on continuity. They have asked. Not many years they have asked, only some years they have asked. If f of x equals 3 sin pi x, 3 sin pi x divided by 5x, x not equal to 0. When they give not equal to 0, there is no need of finding left hand and right hand limit. And in fact, the problems given in the CET, they will avoid you using both LH and RHL. So directly we can do it. Otherwise, it takes time. That's why they don't give. This is equal to 2k when x is equal to 0. Is continuous at x is equal to 0. Find k. See here, one thing you should understand. F dash of 0 is given to be 2k. Sorry, f of 0 is given to be 2k. But x is equal to that is 2k. You have to find the limit. So limit of this x tends to 0, 3 sin pi x divided by pi x into pi by 5. So while working the problem itself, you should understand pi x is there. I need pi x. So when I write pi x, I should compensate by multiplying here, and the 5 I am taking outside. This is going to be the answer. 3 pi by. What's the condition for continuity? Limit extends to f of x should be equal to f of a. So this is limit extends to a of f of x should be equal to f of a for the function to be continuous. Of course, there are other two conditions. LHL should exist or but you can remember this. So because they are given continuous, this must be equal to k. Not k, it is equal to 2k. So what is k? K is equal to 3 pi by 2. Just to confuse it, they are given 2k. Another year, they have given a similar problem. Let me work that also. They normally repeat the same concept. F of x is equal to 3x minus 8. 3x minus 8 if x less than or equal to 5. And 2k if x is greater than 5. Is continuous at x is equal to 5. Is continuous at x is equal to 5. Find k. So you can just substitute here limit of x tends to 5 of 3x minus 8 is equal to 15 minus 8, that is equal to 7, that is equal to 2k. So k is equal to 7 pi. I worked it out fast because the previous problem we have discussed the concept. So what happens is normally they repeat the same problem with the minor changes. So it should not take more time for you to work that. I think with this we shall close our class today. And tomorrow I'll be discussing the problems of integration. The problem differentiation, very few problems have been asked in the examination, which I have discussed. Integration I am discussing. So let me summarize what we did today. The first suggestion I give you is remember the answer. Answer for some problems. X to the power of m into y to the power of n is equal to x plus y to the power of m plus n. dy by dx is y by x. Or log of x minus x plus 1 minus x square. dy by dx is root of 1 minus x. Y is equal to log of secant theta plus tan theta. dy by dx is equal to secant. How to remember integration of secant theta is log of secant theta plus. So some of the problems of integration may be asked here. So if you can recall the definitions, you can save a lot of time. Normally, such problems are only asked. Or if y is equal to ax to the power of m plus n plus 1 or b over x to the power of n. What is dy by dx? N into n plus 1 into y. Sorry. What is x square and d square by dx? That's a standard problem. So the moment you see the answer n into n plus 1, it should flash to you. There's a problem given. So just list out those problems where you can remember the answers so that you can save a lot of time. So these are the few instructions I just want to give you. And there are some problems which I want to discuss. Today it's not study here. Okay. If possible, I will only give you some of the problems, the standard problems for which you need to remember the answer. I have to sit and write it out. I'll do that. So tomorrow we will discuss problem of integration. So what is the homework for you? All the standard results of integration. Dx over 1 plus x square is tan inverse x. Or a square plus x square is 1 by a tan inverse x by a. Supposing it is given as 3x over x square plus 25, it is 1 by 5 tan inverse. Supposing you are given dx over 4x square plus 25. I think you have discussed this while discussing the question papers. So what is the answer for this? 1 by 5 tan inverse 2x by 5. This becomes 1 by 10. Why 1 by 10? Because you are writing this as 2x whole square plus 5 square. Supposing you are given dx over 4 minus 3x whole square plus 16. The answer is minus 1 by 12 tan inverse 4 minus 3x by 4. If you can understand this, the problem is over. See the difference? This is a square, x square is a square, x by a. But how do I get 1 minus 1 by 12? This is 1 by a. Differentiation of 4 minus 3x is minus 3. Let me write one more problem. Dx over root of 5 minus 3x whole square. Sorry, 16 minus of 4 minus 3x whole square. What is the answer for this? The answer for this is 1 by 3 sin inverse 4 minus 3x by 4. What is the standard result? Dx over root of a square minus x square is sin inverse x by a. So x by a, differentiation of this we should take. And there is no 1 by a. See if you can recall this, tomorrow's class is going to be easy for you. Normally what we do in the regular classes, when 4x square minus 25 is given, so first step we are going to write dx over 2x whole square plus 5 square, then put here 2x is equal to t and all that. That's a normal procedure, but I have suggested this while discussing the integration problems, and I have just given an idea. You should differentiate that. What happens in this case? Difference of x is 1, therefore it will not change. Supposing it is 9x square, we will get 1 by 3. Supposing it is 3x square, we will get root 3. 3x square is written as root 3x whole square. If you are given a problem, integration of dx over 3x square plus 7, the answer is going to be 1 by root 21 tan inverse root 3x by root 7. Yes. So I have given you some ideas. Try to develop these ideas by working some problems. Then in tomorrow's class, you can follow easily. Next thing is, wherever required, I will just revise it. But if I start revising only that, I will not be able to complete both portions. So I'll be just, some places I may just remind you. Otherwise, I'll take it for granted that you are aware of this. You got differentiate a term, and whatever you get, that you should divide 1 by a into that. Okay. Thank you. We shall continue tomorrow. Good night.